For today's talk, I just want to share with you how I work to align my work with my values. Okay, and I don't really want or need you to walk out of this talk embracing my values, but I just hope that you're inspired to think about yours a bit more and to realize them in the work that you do. Okay, and with that, let's talk a little bit about computational ecosystems and what I think they can do for advancing human values. Okay, so just to start my talk, I just want to pump us up a little bit by assuring you that HCI and computing has made a tremendous impact on the world, right? So if you look at the figure on the right, certainly looks like HCI has touched every facet of human life, and that we're all benefiting, if not impacted, from its advances. But when it comes to my research, I keep hitting upon this question. How can we solve human problems and advance human values that remain unaddressed even after decades of advances in computing and in HCI? Okay. So just to be clear, as someone who designs technologies, this is a really unfortunate question for me to be asking, especially when HCI is totally winning, right? But with computing moving so fast, I think it's really easy to focus on progressing, then on taking a step back and looking at the areas where, despite advances elsewhere, we're really no better for it. Okay. As a small example of this, I want to briefly show you a picture of my students and I, just my students, in the Design, Technology, and Research program at Northwestern, where I work with students on independent research. Okay. I've had a lot of successful students over the years, but my question here is really simple. How come there's no technology that helps me mentor them better? Despite decades of computing advances, why is the best mentoring technology a notepad? What is a mentoring technology anyway? Okay. So questions like this got me thinking that maybe it isn't a lack of technology, like that's not the issue, but a lack of reflection on how we design technology, or what Philip Augury calls a critical technical practice. Right? And this is the kind of reflection and practice that my students and I have been engaged in for over a decade now. And through it, we learned some really important things. The first thing we learned is that for many human problems, there are fundamental limitations in our current approach and ways of doing things that cannot be overcome with better technology. If we could, we would have done it already. Okay. And instead, what we need is a new approach, a new way of doing things. That what's broken is not only our technology that supports our current ways of doing things, but our way of doing things in and of itself. And finally, we learned that we can't enable this new approach without a radical reworking of the socio-technical configuration, right? That ultimately, what we need to redesign is not simply a technology, but instead the entire socio-technical ecosystem in which we operate. So to illustrate the value of thinking this way, I want to start the talk by showing you 5 human activities that we made better through this approach, starting with planning large events. Okay. This is work I led almost 10 years ago now, or more than 10 years ago now, with some folks that you may recognize when we were all a lot younger. Okay, so photos online can be deceiving. Be careful what you're looking for. Okay, so let's get started on this. What I'm showing you here is a picture of a handful of ACs coming up with a preliminary schedule for CHI, the big HCI conference. Okay, so they do this over 2 days where they're in this room and they're trying to construct sessions on paper. Okay, and immediately you see that there's some problems with this approach, right? And the first is that the organizers, despite their best intentions, lack information about the diverse preferences, constraints, and knowledge that's held by the larger community. Right? And the second is that they lack some tools for managing the complexity of the schedule. Right? And the problem isn't that there's no optimizers around, but that without a clear sense of how the papers are related and what preferences and constraints people have, you can't just run an optimizer to find the best schedule, no matter how good your optimizer is. Right? So instead of focusing just on building better scheduling software, we reimagined the process of planning itself and just came up with a new approach that we call community-informed planning. Right? And our first core idea is to engage the entire community in the planning process, whether that's asking committee members to make sessions, collecting paper affinities from authors, or collecting preferences from attendees. And as we did this, we thought about ways how to collect information from one group of people, like certain community members like authors, but in ways that actually are helpful to attendees and that promote them contributing even more useful data. And once we gathered all this community source data, our second core idea is a community-informed mixed initiative interface that puts organizers in the driver's seat and provides a holistic view of all the constraints and preferences that we've collected so far. Right? So let me show you how this works. This tool gives the organizers a multidimensional view of the schedule and allows them to make changes that are based on their goals and tacit knowledge, the community's input, and the system's intelligence. Okay, so what I'm showing you here is that the organizers are finding the session that has a lot of conflicts, and they want to swap it or move it to somewhere else. And the system recommends sessions that might make good swaps based on what the system knows about, right? That despite all the information that's collected so far, the system doesn't know everything, but it provides the organizers with useful guidance on what may be good options and what may not be, while retaining control over the scheduling itself. Right? So it's still a very human-driven process. We deployed this system at CHI and CSCW and achieved the following outcomes. Right? So we engaged over 1,500 community members in planning, reduced organizers' planning time by more than an order of magnitude, and resolved hundreds of previously hidden conflicts. Okay? But the favorite part I have of this graph is actually that red line, which shows the number of conflicts going down over time. But my favorite part is actually the flattish portion in the middle, where the number of conflicts aren't really going down all that much. Because what's happening there, and what's interesting, is that the organizers were able to improve the schedule even when that was happening. And what our process allowed is for them to not only engage in this consequential task of resolving conflicts, but to exhibit their care for creating a good schedule and for shaping a good conference. Okay, this is a really important idea that I'm going to get back to later in my talk. All right, so let's move on and look at this challenge of coordinating. They are maybe using some parts of it, and I could say a little bit more about that. So one of the things is that what you need to learn how to use isn't just one software anymore. It's how to organize this larger community effort, if that makes sense, right? And I think one of the things is that the ACs, or not the chairs, just pass on from quarter to quarter, year to year, and we lose a lot of that community knowledge, right? And that's really what's difficult. And then there's also some annoying things with gluing to PCS that like changes every year. That's annoying. So, and we just all became faculty, so we're doing our other things. Okay, all right. So let's move on to look at the challenge of coordinating on local problems. This is work led by my former PhD student, Young-Sun Kim, who's now at Adobe. So what we're interested in here is mobilizing crowds to solve local problems, right? Many of us use crowds to help us today, whether that's for getting rides on Uber or for food delivery. Okay. And many of us may even participate in citizen crowds, right? Whether that's to report local problems using 311 or See Click Fix, or contributing to citizen science efforts such as tracking bird migration patterns. But even after 2 decades of advances and many successful systems, basically, we still just have 2 approaches for mobilizing crowds, right? And the first one is this directed approach where we just tell people what we need from them, and this works great for getting things done, but usually requires paying people with strong incentives, which works in some settings, but not others. The other approach is that you just let people opportunistically contribute whenever they feel like it, and this can mobilize many volunteers, but struggle to coordinate them in ways that ensure good system outcomes. Like, for example, whether there's good coverage across a region, or ensuring timely responses. So instead of settling for either of these approaches, we began to rethink how we could coordinate in an entirely different way, which we call flexible coordination. Okay? And the way it works is that we ask for contributions from people who are on the go, just going about their day, and do so when it's convenient and of interest to them and valuable for system goals, right? And yes, that is right. Okay. And the key idea here is that we don't want to think of coordination as enforcing rigid ways of working and of collaborating that are predetermined. Okay? Instead, we want to listen for opportunities and to ping people whenever good opportunities actually arise. Okay? So let me show you how this works in practice. An example of this approach is a system we built called Hit or Wait that applies decision theory to determine whether to engage people in tasks by considering both current and future opportunities for engagement. Okay? And what I'm showing you here is a lost and found task where we're trying to search for a lost item across those 5 regions, but where everyone helps or who's helping may only spend 5 or 10 seconds right? So you're literally just walking by this region, you're asked to help, you kind of go like, yep, maybe, right? And you just keep walking by, right? So very low effort. Let me show you the system in action, right? So what you're seeing is people passing by different regions, and as they do, the system's making these decisions on whether to ping someone, not necessarily at the first region they hit, but also by predicting which regions might come later, where their help might be more valued by the system. Right? And computationally, this is really cool, because you can achieve outcomes that are almost optimal, assuming you knew where people were going to be ahead of time, which of course you don't. Okay? But what's really cool practically is that by doing this, you get entirely new forms of local services and communities that are volunteer-based, but that are surprisingly effective and that are quite different than what we're used to. Right? So what you're seeing on the left are images of people helping one another pick up and deliver packages and finding some really hard to find items. And what you're seeing on the right is a service that's like Google Places, but where you could get these additional dynamically sourced community information, like whether they're seating by outlets that are by the window of that coffee shop. So what's really exciting to me isn't just that these services work, it's that they empower people to express care and to help others in these small and convenient ways, but where their contributions end up being genuinely valuable to their community. Okay? And that's really the value of the system. All right, so let's shift gears from solving local problems to thinking about connecting with friends and loved ones who are at distance. Right? This is work led by my former PhD student, Ryan Louie, and by Jenny and Allison, who are undergrads in DTR. Okay, so social media has been with us for a while now, but even today, so much of social media is just scrolling through people's past lives. Okay, so I'm scrolling, and you're scrolling, right? And now we're all scrolling, right? But we're not really like engaging much with one another, right? We're kind of just scrolling past each other, and somehow we got logged into this paradigm and haven't really reconsidered how we connect with one another for quite some time. Okay. So our research led us to a totally different approach, which we call opportunistic collective experiences, or OCEs. Right? And OCEs are computer programs that find opportunities for friends and loved ones to engage in shared activities and to connect at distance. Right? So these interactions are grounded in people's physical environments, and they're only presented when the affordances in people's current places allow them to come together in the desired ways. To do this, we completely rethought what connecting at distance looks like, both interactionally and technology-wise. Right? So what I'm showing you on the left is a novel interaction model for connecting at distance, for instance, when people are in similar situations, or when they could contribute to shared goals. We read a lot of the literature on social connections and thought about how what facilitates connecting in person can be translated for this remote setting where people, for example, can't easily attend to the same stimuli. Right? They're not in the same place. To make this possible, we built a programming model and coordination engine that recognizes when the right conditions for connecting arises, and also tools for expressing human situations and experiences to machines, such as what are good places for sharing a warm meal on a cold day. And when we do this, we find that we can create a social technology that's more connecting, that has fewer barriers to initiating connection, and also that just leads to entirely new experiences. Right? So what I'm showing you on the left is that OCEs are just as connecting as direct messaging, and much more connecting than reading posts and replies on social media. But unlike direct messaging, people find OCEs much easier to engage with throughout their day, where with direct messaging, the longer you wait, the harder it is to reach out to someone. Right? So you can wait a few hours, but then you read a few days, and then if you haven't messaged your friend in a month, right, it starts to get really difficult. And participants felt that using OCEs, you're just more involved in the other person's life, and just knowing that what I was doing was explicitly something that my friend was doing as well. Not only was it a reminder of them, it's a reminder that I'm around too. People were able to just have all kinds of different experiences, like taking those half-half photos. You can also watch the sunset together with your friends around the country, around the world, where you can actually see the whole sunset in a single moment. If you think about that, like, because the sun's like in different spots. Okay, cool. Right? And people were also illustrating and telling stories together that were grounded in their physical environments. And what's really exciting about all this is it just demonstrates that we're not doomed to scrolling past each other, right? That if we're willing to rethink how connections may look like, we can have really different relational experiences, even when we're far apart. All right, so moving on, let's talk about learning to build software. For about a decade now, my students Job Hishman, Sarah Lim, who's at Berkeley, and Gobi Dasu, who's a Stanford grad, have been reimagining how novice developers learn the conceptual knowledge and ways of thinking that professionals have and what that transition from novice to professional may look like. So at the core, as we looked into this problem, what we saw is that our learning resources just aren't made for this, right? So on one hand, we have tutorials, but they're not quite right? So on the top left, what you're looking at is actually the Airbnb's search bar, okay? And then on the bottom left is something that, like, it's a tutorial for making something that's kind of like it, right? But not quite. And the thing is that the Airbnb one is just nicer, okay? And knowing how to build the tutorial one on the bottom, it doesn't really mean you could build a nice one on top, okay? And on the right, what I'm showing you is that, of course, you could inspect Airbnb source code, but it's completely overwhelming for a novice, and it's not clear at all how they actually built it, right? So I know there's been better developer tools over the years, but these tools are still largely designed for experts and not novices. So in our work, we took an entirely different approach, which we call readily available learning experiences. And the key idea is that we're going to transform all professional websites into a learning resource for novices, right? So instead of relegating novices to simpler tutorials, we're just going to support them in making sense of complex code directly. So let me show you what this looks like through a tool called Isopleth. So what you're seeing here is an interactive website of the New York City skyline from National Geographic. Instead of looking at the source code through an inspector, Isopleth provides these visual representations that helps a learner see and understand hidden event-driven relationships and function calls. It gives learners a way to build on their intuitive understanding. So for example, what's the code around mouse and keyboard events? But also to engage in the modes of thinking of the discipline. For example, by focusing in on Ajax calls. And when we do this and create what we call learner-centric developer tools, we find that they're really effective. We found significant improvements in both program comprehension and replication tasks than existing approaches for learning JavaScript and CSS from professional examples. And Apply is now actually in all major browsers, so even novices can figure out what's going on in the CSS of any website. And while we could have just stopped there, we actually went further and found that novices struggle not only with having good tools, but really with having good strategies for sense-making and for learning. Okay, so for example, when you give novices a stack of these professional examples of web layouts, what we found what novices struggle with is really having good strategies for looking beyond surface-level differences across these examples, building their understanding over time, and transferring that understanding across the examples as they were looking at them. This led us to focus not only on providing novices with better tools, but on creating scaffolds for managing their sense-making process. Right? So at the time we were doing this, we're actually reading about how people make sense of historical documents, right? And thinking a lot about how learning can happen when people are looking at very complex artifacts, but that are slightly different across a set. Okay. So we created these scaffolds, and then we embedded them in software, which completely changed the ways that novices approach the professional examples in the first place. Across 3 systems, we found that managing the sense-making process in this way to target conceptual learning outcomes led to significant learner gains in modeling JavaScript data flow, in mastering CSS techniques, and understanding design patterns in Python. Right. So what we did here wasn't just to build a better tutorial or a better code inspector, but instead it's to change the practice of how novices engage with expert work. Right? And the key idea here is that in our approach, learning happens through participation in expert practice, not apart from it. Okay, so finally, let's talk about innovating through research. This is work led by my PhD student, Alicia Maliakal, who's now faculty at NEIU. So I want to go back to this question about how we train the next generation of researchers, and I want us to think about why is this so hard? In particular, what's needed for students to be able to drive research themselves. So it turns out that to become self-directed researchers, students need what are called regulation skills, or cognitive, metacognitive, motivational, and emotional skills that are needed to plan and to seek help while doing their research. Okay? Now, without them, students can often get stuck doing rote tasks, or they could just struggle to make progress and need to wait for their faculty mentors to come rescue them just to get them back on track. And the sad thing is that as faculty mentors, we don't always do a good job of teaching these skills, and our advisors never taught us these skills explicitly either. Okay. And as a result, many students end up banging their head against the wall while they're doing research. And my contention here is just that there's got to be a better way. To address this challenge, we created a socio-technical system that we call Agile Research Studios that provides a model for research training within a community where all students, regardless of how senior they are going to receive authentic research practice, by which I mean that they all engage in this self-directed learning cycle where they set goals, learn, plan, make progress, reflect, before doing it all over again next week. At its core, what ARS is, it's a socio-technical model with processes, social structures, and tools that work well together to help students develop these regulation skills. And to do this, we fundamentally reconfigured the roles and relationships of student researchers and mentors, and then created technologies that facilitate this reconfiguration. Let me first describe how this model supports students learning how to plan research work. Right? For us, planning isn't simply figure out what your tasks are for the week. Instead, it's a process of learning to represent and visualize your existing understanding, diagnosing risks in that understanding, and then focusing plans on those key risks. We created entire subsystems or socio-technical configurations for learning each of these subskills and for students to connect these skills so they could link their problem understanding to their risks and their risks to their plans. And together, this provides a way for students to deepen their practice in how they drive research themselves, right? So the goal and the focus here really isn't to troubleshoot and to help the student make progress immediately as fast as possible. It's really to help the student learn how to fish so that they could fish for themselves, so to speak. Okay. Yeah?
I have a question. So,
please.
The previous framework is really nice and very insightful. To some extent, I feel like based on my experience of working with students, sometimes motivation is really the key there.
Yeah.
In this framework, how do you ensure that students have the right motivation to follow each step?
Yeah, great question. I'm going to get to that in the second part of my talk. And if I still don't answer it, ask again, please. Yeah, it's so important. Yeah, it's so important. Yeah, in the first part, we'll stay cognitive. But in the second part, we'll talk about that. Although even my next slide is kind of about that, right? So on the help side, instead of students like having to wait for me to be the solo help giver, ARS really distributes help across the entire community. So for example, during studio meetings, students sign up for something called pair research, where students just put in what they need help with, and other students rate how well they could help, and then we run a matching algorithm. And the students are paired up to help each other. And this lets us not only maximally use the expertise that's within our community, it just leads to our students getting a ton of help from different students, both within the research area, as shown in the same colors, and across research areas as well, right? Because some of the things you need help on don't always rely on domain expertise in your domain. It might be about writing, building software, whatever. But what I get excited about is actually the quote on the right. So seeing students really have these shifts in their views about help seeking, right? So the student said, I can ask for help, that everyone asks for help, and it doesn't make them stupid to need help, right? And this is really promising to see because even our best students can really struggle with asking for help. Right? Because it's somehow not okay to say that I don't know something and I need your help. So in 11 years, in my own studio at Northwestern, I've directly mentored 180 plus students who worked on 70 plus research projects. I'm excited to share that half of these students are women, and that these students won a bunch of undergraduate research grants, published lots of papers, won major student research competitions, and that many of them end up around here in Palo Alto, working at these big tech companies, and others have founded their own companies as well. Okay. And this is all really exciting, and we've been sharing our success beyond Northwestern as well, where we're supporting 70 plus other faculty who are using our model to support their students back home. About, it varies, but 15 to 20 is about the size of the cohort. Yeah. Yeah. Beyond that, my life gets difficult. Yeah. But 15 to 20 I can handle. So in 2022, we released the DTR documentary Forward, just to further share our culture of learning and growing. And it's just one of the things where we don't really see how the sausage is made in research. So I just really wanted for us to be able to have dialogue about how do we actually do the thing that leads to the papers and whatever else that we produce. Okay. I also began to write these DTR annual letters, again, to initiate more dialogue on learning and growing, and to talk about the challenges that we face as mentors and that students face on their end as well. And I actually, with this help, have copies of the 2025 DTR annual letters. So if you're interested, feel free to just grab a copy on your way out. Okay, so I've shared a lot so far, and I'm about at the middle of my talk. So any questions about any of these particular systems? And then I'm going to say a little bit that summarizes what we're trying to do across these systems. Yeah, go ahead.
So for the first couple there, I was wondering about privacy.
Yeah.
I mean, if I see other people's tracks and know where they're going, the bad things you can do.
Yeah, I think you're talking about the second example where we're doing that. Yeah, so we're not showing the tracks to anyone else. So yes, we are still getting where people are walking and tracking that, and people are consenting to do that. But I hear your concern about privacy. But for the system to do its optimization, it doesn't need to share any of the information to other people, right? But I think thinking about privacy is important in systems like this. So I'm with you there.
There are methods of doing that that are on the cipher.
Well, yeah, I'd be happy to hear more about it. Thanks. Yeah.
Oh, I think this is about the coordinate on local problems.
Sure.
And the way you described it, it's almost like there's this proactive interaction, right? Like
Yes.
where as you know their location, and then you can
Yes.
say, hey, look around, that kind of thing.
Yeah, if you want to help, right.
Yeah, exactly. So that's exactly the question of how do you balance the so how do you have a mental model of the user that's to be proactive without being annoying?
Yeah.
And also is that uniform across people?
Yeah. We did actually do some work on there, and clearly Google hasn't quite figured this out.
Yeah, I was gonna say.
While I'm driving, because it seems to freaking keep asking me about, right? So yeah, I mean, there's a whole literature on interruptions and disruptions, right? And you can think about that and build models of users. I don't think it's uniform across people. I think some people have higher tolerance, but the people who have higher tolerance might have lower tolerance if you abuse that tolerance, right? So it is something to think about. I think what's really exciting for me about the system I showed you is that it's such a small ask, and it's so effective despite the small ask, right? And I think the thing that I'm really demonstrating is that just with a little bit more thoughtfulness about how we coordinate, you could get really good solutions without having to be nearly as annoying, right? And that's really the idea. Yeah. Okay, good. Any other questions at this point? Everyone good? Okay, I'll pause again pretty soon, so there'll be another opportunity. So I just want to summarize a little bit, right? So in each of these activities we looked at, there were fundamental limitations with existing approaches that could not be overcome with technology alone. So what we did is to take a new approach, and in doing so, we created entirely new socio-technical configurations to support it that we call computational ecosystems. And what computational ecosystems are systems, but that are not designed piecemeal, but instead as integrative solutions, where practices, interactional structures, and technologies are conceived of together and brought together as one coherent whole. Right? Typically, when we design socio-technical systems, we tend to do it layer by layer. We start with a practice of how we do things, then we shape some social structures around it, and then finally, we build tools that support both of those things. And this is actually a really thoughtful approach to design, especially if the existing practices can't change. But if we can't change the practice, why should we assume that our practices have to stay fixed? You could often get much better solutions that we've demonstrated across these 5 examples if you're willing to reconsider changing all 3 layers at the same time. Right? So in other words, computational ecosystems free us to explore more creative solutions that are more likely to succeed when our existing ways of doing things are fundamentally limited. And our focus on the systems approach to design echoes calls from folks like Atul Gawande at the Harvard Medical School, who says, we've been obsessed in medicine with components, want the best drugs, best technologies, the best specialists, but we don't think too much about how it all comes together. It's terrible design strategy, actually. And Atul goes on to say that making systems work is the great task of our generation of physicians and scientists. Go further to say that making systems work, whether that's in healthcare, education, climate change, or making a way out of poverty, is the great task of our generation as a whole. I think in HCI, we're still not doing our part in thinking systemically enough. But when we do, I think we can not only have the impact that we've already had, but can start to address some of the fundamental human problems and values that we've largely neglected, if not created. But before I get you too excited, I do want to note that doing research this way is not easy. That my students and I often start by trying many existing approaches, but where none of them work and we get nowhere. Okay? And even after we arrive at a new approach, it often requires years of intense study, both inside and outside of computer science, as we explore and iterate on new social and technical configurations that might be better for this problem. And as these ecosystems mature, we develop these increasingly sophisticated systems with many components and work to gather evidence across multiple real-world deployments, which just takes a lot of time. Okay? And after all that work, and perhaps because of it, often other human values that remain unaddressed become legible to us. And then we're like, oh man, we got to do this again, right? And they challenge us to reformulate and reconfigure our ecosystem yet again. I'll show you an example of this next. Right? So while I think this work is really important, I just want to be transparent about the years and maybe decades of work that this takes and the depth of understanding and the complexity of system building and studying that goes into designing even a single computational ecosystem. Okay, so before I move on to the second part of my talk, I just want to pause here. Any questions about the approach and this summary? Yeah, please.
I just wonder if you're going to cover this. So with generative AI, I think the education, learning, even mentoring has changed a lot. How do you see the role of generative AI in influencing the framework you are proposing?
Yeah. I think of generative AI as another great component. And we should really be thinking about it as a strong component, but also to take this opportunity to think about whether there are opportunities for radical reconfigurations of how we do things, not only of how generative AI can help us make more efficient our existing ways of doing things. Right? There might be things we're just missing in the bigger picture, and my goal is for us to use these technologies in space to re-look, to re-examine what we're trying to do. Right. The other thing I'll say, and this may or may not be kosher here at Stanford, is that everything I talk about today will not use generative AI. Right? I'm going to introduce to you 5 so far, 2 more coming, solutions to problems that I think are state of the art, but generative AI did not take part in any of them. Right? And that's something that I want us to not see like, oh, that's so cool, but just to understand, why is that? Right? Why is it that for these problems we're solving, we're not using generative AI yet, although we're gonna, but where our approach just somehow works better. Okay, so yeah, it's a really good question, and I do want to work with that. Yeah.
I'm wondering about the interplay of the social and technical.
Yes.
And because, like, for example, in the help and help seeking example that you gave,
Yes.
the social dynamics that you're talking about are created without the tools in certain places, like a design studio, like an architecture studio, right?
Yes.
So I'm just curious how you go about, I guess, thinking about that, and to what extent does having tools to facilitate that creates an over-reliance on the tool as a facilitator rather than like creating the culture around it, or actually does it help, right?
So I'm really curious.
You're asking exactly the right questions, right? And I think in our uses of it, we found that they're actually mutually reinforcing. You need a community of people who like each other enough. And when you happen to get help from 10 to a dozen people every quarter, you kind of feel different. You're like, wait, this is awesome, right? My students go off to places like here and elsewhere, and they're like, oh yeah, help seeking, like, or hey, like they build communities. So it kind of goes both ways where the culture, you need enough culture to even do this practice, but the practice actually makes it normal to help everyone. right? And that's, I think, that kind of socio-technical rethinking as well, where it's like, we sometimes think it has to be one direction or the other, but it's like, let's try it. And then, but we might also notice, it's like, oh, wait, are people over-reliant to this too, and they're not getting help outside? And that's something that we could kind of consider in that question as well, right? So I think in that critical technical practice approach that I was describing at the very beginning, the questions you were asking are perfect, because those are the questions we continue to ask, right? And it's through continuing to look at that things evolve and that we think, yeah, exactly. Perfect. Okay, all right. So I do want to move on to the second part of my talk, because so far, we've looked at examples of computational ecosystem that open up entirely new ways of doing things. But in this next part of my talk, I want to ask a deeper question. What are computational ecosystems actually good for? So is it just about having better ways to solve problems? Or can they contribute something else, something intrinsically valuable that individual technologies fundamentally cannot do? Okay, and I actually think they do, and this has really changed my thinking around how to think about socio-technical systems. And I just want to give you two examples, okay? So the first is that computational ecosystems can create spaces for people to grow by supporting them in developing a self and a practice, okay? And this is work led by my PhD student, Kapil Garg, who's now at UC Irvine. So let's go back to DTR for a minute, and this is touching on Dee's question. While we do train students to produce research, I just have a minor apology. I lied a little bit, or I withheld some information in the first part of my talk, right? This producing research thing, that's actually not our main focus in DTR. Okay, in DTR, we use independent research as a vehicle for students to learn about themselves and to grow as people. That's our main mission. Okay, so let me show you what I mean by that by reading you this quote from a DTR alum. Okay, so she said, "Thank you so much for teaching me how to advocate for myself and my ideas, to embrace failure and inexperience, and search for truth rather than BS." Okay. Right? So just notice that what's most important here is not just producing research, but how this student has come to see herself differently. And the question I have is, well, how does the space for research training provide for this kind of learning and growth? And also, what does this kind of personal growth have to do with doing research anyway? So to begin answering these questions, I want to start by highlighting just how many regulation skills are involved in self-directing research and in learning to innovate. Okay, so another, sorry, white lie, right? I talked about planning and help seeking before. There are actually just 2 skills out of many skills that you actually need, right? And the truth is it's not actually easy for students to learn and to be good at any of these skills, let alone all of them, right? And some of them are motivational as well. So all kinds of scaffolding can help, and our lab has created many of these scaffolds. But it turns out that good coaching really matters because ultimately it's about the person. So a core challenge is that understanding and addressing gaps in a student's practice and regulation turns out to just be really complicated, right? We understand that students' work outputs are not everything, and that if we want students to grow, we're going to need them to learn better work practices, and even more than that, to have better ways of regulating their work and their learning. However, this is often not what we focused on, even in project-based learning environments, right? A lot of effort goes into understanding a student's work output and troubleshooting the student's work output so they could make progress. There's often little focus on understanding how a student's practicing and regulating, even when those are actually the desired learning outcomes. So to address this, we developed a mentoring practice and tool called Cap Notes, where coaches focus on addressing gaps in a student's practice and regulation and not just on their work output, right? So during a coaching session, a coach is still going to note practical issues of concern, such as when Stella's prototype is missing a key feature, okay? But instead of just telling her to fix it, we really try to understand, why is this happening in the first place? And what we might uncover is that Stella actually just lacks strategies for slicing work to risk, in which every week she might prioritize delivering software or having something to show over actually having new understanding each week. We also find that she tends to overwork when she's overwhelmed, which can often lead her to just do ineffective work despite spending a lot of hours. So with this process and tool, a coach focuses on building this richer model of a student's regulation behaviors and practices, and on addressing any regulation gaps that are uncovered and not only on advancing the work output. To make this possible, we created something we call practice objects, which are computational representations that capture how a student's practice and regulation are evolving over time. So what I'm showing you in this example is that we're tracking the work issues that students have, but instead of just these were the work issues, they're being linked to the students' underlying regulation gaps, and the suggested practices are not just to troubleshoot, but to give students practice on the thing that they're really struggling that's making it difficult for them to do this work in the first place, in what we call a regulation-informed practice. What's really exciting about this to me is that we're actually tracking these regulation gaps over time, and it gives us a way to work with students on their underlying patterns. Okay, this is what it looks like before. A student comes in 1 week, they have this issue, you troubleshoot this issue. Next week, they have a different issue, you troubleshoot that issue. Next week, they have another one, right? But actually, what if what's underneath all of that is that the student struggles with running away when they get scared, or whatever it might be that they're struggling with, right? So what this gives us is a way to recognize these patterns, to work with these patterns, but in a way that's still situated to the work issues they're having each week, but where the patterns are actually what's being cared for, not just the surface issues. Okay, so beyond providing computational support, what really shifted for us is that we no longer see self-regulation as just some skill to be built. Okay, we see instead that self-regulation is really a doorway into our seeing students more clearly, and for students to see themselves more clearly. All right, so to do this, we see our students and build strong relationships with them. We hold a ton of space for reflection, sharing, and acceptance. So like on Friday Studio, which is happening right now, running studio today, but we'll spend like 45 minutes to an hour just sitting in a circle talking about how it was like to work this week. Okay, and we recognize that these patterns and beliefs can reoccur and they could be quite sticky, so it's going to take some time. And to create the space for this kind of learning, we really value developing these regulation skills over production. Okay, and to do this, I problematize how students approach problems and look at themselves. And if you're interested in reading more about that, that's in the 2025 DTI annual letter. Okay, so in addition to learning regulation skills, we focus on this challenge of helping students to engage more deeply in research. Personally, what I value about research is that it gives us this opportunity to dance with not knowing, to intensely re-examine phenomenon, and also to see into deeply held beliefs and worldviews that might actually be limiting our ability to see the world clearly. Right? So I think about Darwin, I think about Galileo, and that these goods connect us to this scientific tradition, and they're not largely about producing more papers, but are valuable ways of engaging in research in their own right. Okay? And if you're interested in learning more about that, please refer to these essays in the 2024 and 25 DTI annual letters. So the question is, well, how does one learn to engage more deeply? This is a really complicated question, but a partial answer is that we need to know what gets in the way of people engaging deeply and to work with that, right? And here we see that personal growth is intricately tied to our ability to engage deeply because, for example, when we fear that we're no good, it's really easy to adopt a production-oriented mindset just as a way to prove our worth, right? Our fears of imperfection can lead us to run away from what's actually important in the research, and that our fears of not knowing can lead us to just kind of keep doing the things we're doing the way we do them, even when other ways of doing things might be much more fruitful and helpful for our learning and for our research. Oh, did you get your picture? You good? Okay, cool. I hate it when people go too fast on the slides, and then it's like I can't get the picture. So, okay, if you need me to pause, just always. Okay, all right. I want to share with you this note that I recently received from a student who said that until DTR, I had no awareness how I was tormenting myself or how closed off I was from the world. Came in needing desperately to prove myself, telling myself that I needed to get somewhere. Never occurred to me that a gentler approach was even possible, let alone effective. Taught me to pay attention and helped me become more perceptive of the wonderful world around me. Thank you for giving me the tools to become more self-aware and be able to reflect more meaningfully on what it means to be true to myself. Right, so this note really strikes me because for her and for all of us, how can we engage deeply in research if we can't see the beautiful world around us? How can we seek new knowledge with open eyes? right? So I think we all deserve to feel okay about ourselves and to have the space and the community behind us that makes these valuable ways of learning not only possible, but commonplace. And in DTR, what we have is a computational ecosystem that supports not only our work, but also our growing into who we're becoming. Right? And this focus on becoming has fundamentally changed my views on what research learning is about and on what success looks like. Right? So in DTR, success isn't just sending somebody to grad school, even though I do send them here because you guys train students well, right? But it's also about students growing into themselves and developing the courage and the skills that's needed to pursue a life that's fully their own, in which they tackle the problems that are deeply meaningful to their persons, right? So as examples, Kalina started Big Talk, a social movement to foster more meaningful conversations and to combat loneliness. And her book on Big Talk just came out last week. Penguin Random House, you could go get the book, okay? And then Meg went from leading engineering team at Apple to studying environmental engineering because she wanted to improve the water supply system in the UK, okay? And Catherine was the head of engineering at a sustainable tech startup, but she just spent the last year at the whale and dolphin conservation in Massachusetts because that's what she's really passionate about, right? And I'm excited for these students personally, but broadly, for shifting this dialogue on what is the value of research experiences and what place can it have in our students' lives. Okay, and that's really what we're after in this work. Okay, so just pausing briefly, any questions or any comments on any of this? Please, yes.
Like the community thing that we built. So
Yeah.
you mentioned that students can share about like their challenges that they're facing about like motivation and things like that. So
Yeah.
I'm just wondering how do you get them to actually be comfortable with sharing these, especially if it's an environment where they're working with their peers and their supervisor and people like that.
Yeah. I don't know. I think maybe the way we frame that question is important. I don't know if I get them to do anything.
I think it's like a weekly studio.
I know, but I think the framing is I get them to. And my point is we sit in a circle and it might be quiet for a while and then someone might talk. And then when they talk, we listen. I don't know if I'm getting them to do something. We are there and we hold space. Right? So I do just want to make that slight distinction. But I think those things are really important and they're not things I learned from computer science. They're things I learned from dance communities. They're things I learned from parkour. Right, we can talk about that offline if you want to know about parkour. But like they're really important because it creates also the safety or the space in which we can be with one another. Because my view is, look, if that's really what's getting in the way of your research, shouldn't we have a way to talk about it? Right? And there's a whole bunch of other things. And the DTR annual letter talks quite a bit about how we create this community. I don't know if I use the word get to. Or, yeah. Good question. Thank you. Okay. All right. I'm going to move on just to talk about some other things before I end, but hopefully we'll have a little more time after to chat. Okay. So in this previous example I showed you, it really highlighted how an ecosystem can support our inner growth. And this example is how they could help us navigate the outer world by building computers that can actually understand and support human experiences. Right? This is work led by Jackie and Shirley. She led this work as an undergrad, amazing. And it's an area that we're actively investigating even today. Okay, so when we look at the world through the internet, the thing is, it's really flat, okay? So you could search for cafes in Seattle, you could search for them in New York, you could search for them in Palo Alto, and of course, Yelp is gonna give you a list of what it thinks are the best cafes wherever you are, right? And I don't know if you could quite see it, but the things that it bolds in the cafe descriptions is cozy cafe, cozy cafe, cozy cafe, cozy cafe, cozy cafe, right? Because according to Yelp, what makes a cafe good is just that it's cozy. And that's just what it highlights, and it's pretty flat, right? And this is actually the cost of ubiquity, right? That we build systems that work beautifully everywhere, but in doing so, we replace all these interesting questions about places and experiences with what is the best, right? And that in many ways, we've accepted that this is not only okay, but even desired, right? My own explorations of the world can often be guided and consumed by searching for what's best, and valuing what's best over anything else. But when we look at this Paul Dorsch quote from more than 20 years ago, we see that even back then, we had an increasing understanding on the part of system developers that human activities are enmeshed in a variety of cultural and social practices and relations that make them meaningful by setting a context within which they can be understood. So even 25 years ago, we understood that it's important to more meaningfully capture our experiences in computing systems, right? And done work in this space too. So the question is, why are we where we are today? And it turns out that conceptualizing a human experience across many different contexts is just really hard, right? So unlike cafes, even a simple question like, where do people go to enjoy a long, lingering conversation? It's not really the same everywhere, right? The task is too hard for humans to think about across many contexts. And yet we don't really have a machine solution for this yet either, which leaves us with a pretty nasty socio-technical gap. And what I want to show you briefly is a preview of a computational platform called Differ. What Differ does is that given a human experience, it can automatically analyze how that experience is going to play out in different settings and for different people. So let me show you an example of what Differ can automatically generate. What we see here is that when we define going on a first date as going for somewhere for food and drinks, that's considered romantic. What Differ shows us is that when we define it that way, we're actually left with very few budget-friendly places because romantic means fancy. Right? And that there's much fewer places that are known to be wheelchair accessible or that work for people that are only available early in the day. For example, if they got a night job, right? Or that work for younger people, right? So even with just this one example, what we can already see is a vision for experiential computing where computers can help us to navigate the world in ways that better reflect our shared experiences and also our differences, right? The reality is that the world is really colorful. It's beautifully diverse and full of nuance. But to appreciate its palette, we can't just tweak our algorithms, right? We need to build an internet that's unflattened, one that reflects the richness of our experiences and that inspires us to see that richness when we actually use it. All right, so as an approach to the end of my talk, I just want to emphasize two key points about the role of technology in advancing human values that I think have really important implications for how we move forward in HCI. The first is that advancing individual technologies is insufficient. And the second is that we actually need computational ecosystems, not just for the consequential aims, but also for advancing human values. For my first point, as you've seen throughout this talk, computational ecosystems give us a way to fundamentally change how we do things. Right? When we're willing to rework the entire socio-technical configuration, we can enable practices that are not only more effective, but that better sustain our values. My second point is that we can do more with computational ecosystems than we can with computers alone. At their core, computers are input-output machines that are designed to produce reliable outputs. But what about valuable ways of being human that aren't defined by what we produce or even by the outcomes that we achieve? This isn't to dismiss what computing has accomplished, but to remind us that outcomes alone have never fully captured all that's valuable in being human. In a philosophy paper I published at CHI, I argue that computers can never be the be-all and end-all in promoting human values rooted in intrinsically valuable human activities, right? What are called dialectical activities. I also lay out arguments for how HCI too has been a largely consequentialist enterprise, and as a result, have largely neglected to design for intrinsically valuable human activities. And if you're interested in learning more about this, I brought copies of this as well. Thank you, Caleb. And this leads me back to computational ecosystem, because I think what's really important to remember about them is that they're valuable not just for their productive capacities and solving problems, but for how they challenge and inspire us to engage in activities that are meaningful in and of themselves. Right? So in the two examples I showed you in the second half of my talk, when my students and I were learning to see ourselves more clearly and to engage more deeply in the research, and when we start more meaningful ways of experiencing the world around us, the real contribution of our designs isn't just the outcome they achieved, but it's the ways of being that they inspired. Right? So the real question for all of us in HCI isn't just what can our socio-technical systems produce, but also what kind of lives do they invite us to live? So as I end my talk, I want to leave you with this simple question. Not so simple, okay. Are your values aligned with the solutions that technology provides? Because if they are, that's wonderful. And perhaps you found a way to live a life that feels truly your own within the socio-technical configurations in which we find ourselves, which is also rapidly changing, as you guys know. But if it's not, it's really tempting these days to shift and align your values with what technology provides and live up to what I call technological values. Right? But I think we'll all lose something if we settle for that. And instead, I hope you allow yourself time to find ways to realize your values. Right? That it'll require a ton of patience and new ways of seeing and doing things. But it's still the more interesting question to ask. And at least for me, what I found to be the most fulfilling. And to do that, I think we're going to have to hold on to our values, to know the limits of what technology alone can do, and to build an entirely new ecosystem that sustain meaningful practices and ways of living. We'll need computational thinking to bring all of our human and machine abilities to bear. And we'll also need to think about the larger ecology that we're creating and in which we're all embedded. Right? And in doing all this, my hope is that we'll bridge the ways that we've already embraced design and technology's power, but also with our deepest needs as humans. Okay, so thank you all so much, and I'm happy to take questions.
I have a question. So thanks for the talk. One question is that with the new, I missed a little bit at the beginning of your talk, but I'm assuming you've been doing this for years. So like with the new advances in Gen AI and like AI, have you seen people having a harder time developing these skills, or like more people coming into like the research that you're doing, or like the programs that you have, or like have you seen like it being harder to kind of like guide people to the direction? I mean, like listen to what they're doing.
I think it happened before AI, right? Like how many papers did you have to publish before you even got into the PhD program here? Things have gotten increasingly competitive and consequentialist. And, like my hunch is a lot of you are stressed because jobs are harder to get and everything seems moving faster. And it's really hard to slow down for anybody. So I think that happened before Gen AI, and of course Gen AI accelerated that even more. And we're all where we are here today. And I'm just glad you guys are in this room still. But, to me, it's like, a lot of what I do is pretty unconventional, right? How I work with students. But I think I really am grateful that I still get to do it. I'm at an R1. I'm not at Stanford, but I'm at an R1. And somehow they haven't kicked me out yet for actually slowing down and working with students in the ways that I do. So my point in that is that we sometimes think because of the outside world, we can't live up to our values. And I'm just saying, as one small example, I'm still trying to do that despite how fast things are moving on the outside. Right? And I don't know, maybe generative AI will help us do that, but we're working on that. Yeah, thank you. I'll go this way. And if you're not stressed, don't be stressed.
This was a good talk. Thanks for sharing. You mentioned, you framed this kind of as like a technological issue, right? Like how we interact with technology and whether we can live in our values through that interaction.
Okay.
How much do you see that as like purely a technological problem versus like the higher level social incentives, political incentives that drive that development of technology? How, do you try to like separate those things in your head while you're thinking about it, or what's your framework for that?
Your question is great. I mean, first of all, you're right. It's not just technology. It's all this stuff, right? Like, how many papers you need to do to get into Stanford. It wasn't just technology. It's not just Stanford. It's like the larger right, climate that we're in. No, I just mean that as a technologist myself, you see what I mean? Like, what is my role? How do I examine how I go about creating? Right? So I think of myself as a craftsperson in that sense, where I'm like, I'm creating technologies, I'm putting things out. How do I want my process to be as a craftsperson that is cognizant of, yes, the technology issues, but also a lot of the things that you're talking about, right? And at the same time, again, we do think about it quite a bit because we've somehow got it to work within the systems in which we're embedded still, right? Like we have our own community within DTR, but we're in a university system. The university system is across all of academia. right? So we are thinking about incentives. We are thinking about those things. And what I'm really grateful for is that somehow our students seem to end up at good places like this anyway, despite us, doing all the weird stuff that I do with them, right? So, but they're all important, yeah. I don't have a great framework is the other answer.
So I think the vision you shared of working with students is really insightful and very inspiring to hear. I wonder, throughout the process, do you see different patterns emerging from this process for different type of students? Do students figure out their own way of doing research by scaffolded by you in this process? Are there any different type of styles, patterns you see from this process that you feel could be generalizable to a broader audience?
Yeah, I mean, I don't know. I feel nervous answering this question because I'm looking at my students in the audience. But I think some of the struggles students go through are pretty universal. They manifest in different ways, but they're also just so young, right? I mean, they were reminding me of this yesterday. I was like, you were 19? I forgot, they're so young, right? So it's your identities are forming. There's so much that's happening, and Haoqi is very loud and very scary and very annoying because he keeps, asking you all these questions that you don't want to answer. So, but as we're doing that, I think students are also getting an opportunity to look at themselves and to think about, what do I really want to do and what's making it hard for me to do this, right? And I think some of those things are cognitive. Learning effective representations for thinking, making good arguments are important. But some of those things are not cognitive. There are other things that's going on within the person. And in the subtle, shameless plug, in the DTR annual letters, this year's letter actually starts with a set of patterns that different students have as examples of how they worked and got through those patterns. And I think they're pretty canonical patterns that students would have, probably. Yeah.
Okay, great. Let's thank Haoqi again.
Thank you, everyone.